Hello and welcome to Dr. T Math. In this video we are going to look at some basic number theory and how bigger stuff breaks down into smaller stuff, factorization and then modulo or modular arithmetic. Let's take, for example, the number 162. If we can add up 1 and 6 and 2 and get a number that's divisible by 3, then the entire thing is divisible by 3. 1 and 6 is 7, plus 2 is 9. 9 is divisible by 3, so that's just a phenomenon in the real world of mathematics. That's always true. 162 is then divisible by 3. 3 times 50 is 150, plus 4 more is 162, so we're going to get 54 here. 5 and 4 together is equal to 9. 9 is divisible by 3, and so let's take a 3 out again. And we're going to get 18 there, and then that's going to be broken down into 1 and 8 is divisible by 9. Any number that adds up to a number that's divisible by 9 is also divisible by 3, but let's, for the purposes of this exercise, take a look at a 9 there. 18 is 9 times 2, and then finally we're going to get 3 and 3 again. And so what we are left with here is 162. It's 3 times 3 times 3 squared times 2. And this is a way of showing that our laws of exponents hold true. We've got like bases here. We have exponents of 1 and 1 and 2. And so then our prime factorization is 1 plus 1 plus 2 on the 3 there times 2. So 3 to the 4th is 81. 81 times 2 is 162. And we could, for example, say that x to the 4th times y is equal to 162, and now we've only got one equation and two variables, so we wouldn't be able to solve. But how about if we said that x is equal to 1.5y, since we know that x is 3 and y is 2. Now we can go ahead and solve that. And so we could say, again, bigger stuff breaks down into smaller stuff. Let's look at if x is equal to 1.5y, then we got 1.5 to the 4th times y to the 4th. Or if you wanted to go step by step, 1.5y to the 4th times y is equal to 162. And so 1.5 to the 4th times y to the 4th times y equals 162. And that's where a calculator sure does come in handy. 1.5 to the 4th is going to be equal to 1.5 to the 4th. Just a moment, I've got a calculator here. 1.5 raised to the 4th is 81. Of course it is. Of course. And so 81 times, let's see, y to the 5th . 81 over 16, exactly. Right. I got back to the other screen, like 81, that's not going to work out. 81 over 16, yeah, okay. All right, 81 over 16. And there we are, come on, stay over there. 81 over 16 times y to the 5th equals 162 times 16. We'll multiply 16 times 162. 162 times 16, come on now. 162 times 16 is equal to that. We're going to divide that by 81 now. We're going to get 32. So let's move up. Let's move up here. 32 is equal to y to the 5th. And then we can kind of go through it from there. But we already know that it's equal to 2. See on the big calculator here, where is, what can we do? Let's do 32. We're going to raise that to the 1/5. And that should do it for us, 2. Okay, so if y equals 2, y equals 2, and then x is equal to 1.5 times 2, or 3. So bigger stuff is broken down into smaller stuff. And where does that really lead us? Well, say you're a computer scientist, or maybe you're a clockmaker or something like that. Or if you're a computer scientist and you've got like all these different bits to split up into some packets, and each of the packets has to be the same number of bits. And you want to know, like, how many packets of 8 bits each can you send out? Well, you could either do prime factorization. You can have the computer crunch the numbers, and it will do it very quickly. Or you could use, for example, a modulo function. Let's take this and break it down into factors. First 2 gives us 500. Any even number is always divisible by 2. It's going to give us 250. Any even number is always divisible by 2. It gives us 125. And that's going to be 5, 25, 5, and 5. That's a convenient number. 2 cubed times 5 cubed. And conveniently, I said that we wanted to break it down into a bunch of packets of 8 bits each. 8 times 125, or 5 cubed, is equal to 1,000. So if we had 1,000 bits and we wanted to break it down into bite-sized pieces and send it out in so many files, then that number of files or that number of packets would be 125. We could also go to the calculator and do what's called a mod function. And the simplest way, I mean, you can imagine this like a cycle, like a clock. If there is 0 remainder on any number, then you go around one full cycle. So if you're dividing by 4, for example, then you're going to go around to 4, and then 8, and then 12, and then 16. And each time you get all the way around the cycle, you're going to have an R0, and that's going to be a mod left over of 0. And so we're going to say, oops, other way. We're going to say 1,000 mod 8 is really, what we're asking for is the remainder. The remainder, here we are at number, remainder, we want 1,008. This is really a mod function. It gives us 0. Now if we wanted to break that down into, I don't know, 10-bit packets, or let's do 12-bit packets, then we're going to have some leftovers. 1,000 and mod 12 will give us a remainder of 4. So we're going to have, it doesn't tell us what the outcome is, like how many times does 1,000, how many times does 12 go into 1,000? Well, we'll have to do that separately. 83 times, and then we're going to have that mod function is going to give us only the leftover. How many are left over? And ideally, in a computer, you want to have as little fragmentation as possible, and so you want to keep these groupings. You want to have that mod turn out to be 0. 1,000 mod 8 equals 0, and that is the best way to send stuff in a computer. So big stuff is broken down into small stuff. And the same goes for, like, say we've got a polynomial function, or we've got some binomial, we've got some statement that has multiple terms, and in those terms you might have multiple variables that are raised to some exponents. They might even have, well, it's just for the sake of simplicity here to demonstrate the main idea. We're going to have exponents. They could have roots, they could have negative exponents, they could have a lot of different things going on possible. And we're going to multiply, let's put a constant out there too. And we're going to add to that 6x squared y cubed z squared. And so, again, the theme here is that big stuff is made of small stuff. And when doing pure math or algebra, sometimes people look at the big picture and they just see a bunch of letters and numbers, and they kind of turn off because they don't really recognize that each of these little parts has its own value, and they can be split up. They're all next to each other, but they can be split up and put together, and that they are kind of like discrete but also joined together. So we got all these parts, And if we wanted to factor out a common factor, for example, then what we want to do here is look at each of the parts. So 2 and 6. What's the highest common factor that goes into both 2 and 6? Well, it's 2. 2 times 2, or 2 divided by 2 is going to be 1. And then 6 divided by 2 is going to be 3. Then next up, we're going to take the lowest exponent in each. The lowest exponent for each of those variables. For the x is going to be squared. If we take out x squared from x cubed, we're going to get x. If we take out x squared from x squared, we're going to get 1 onto the y's. 4 and 3, the lowest variable is 3. If we take out y cubed from y to the 4th, we're left with y. If we take out y cubed from y cubed, we're going to get 1. And then with the z's, it's going to be 5 and 2. Our lowest exponent is 2, so we're going to have a z squared. If we take out y squared from y to the 5th, we're going to get, if we take out z squared from z to the 5th, we're going to get z cubed. And if we take out z squared from z squared, we're going to get 1. Draw parentheses on here, and we can put them all together. Let's go back and check that. And so 3 times 1 times 1 times 1 is just 3. Get rid of that. Let's expand now. 2 times 1 is 2. 2 times 3 is 6. And then x squared times x is x cubed. X squared times 1 is x squared. And then y cubed times y is y to the 4th. Y cubed times 1 is y cubed. And z squared times z cubed. Now this is the part that a lot of people get confused about. This is the additive property of exponents, because it's not stuff inside of parentheses raised to an exponent. It's just multiplication, really. Like bases multiplied by each other. We're adding the exponents. And then z squared times 1 is z squared. And we're back to the beginning. 2x squared y to the 4th z to the 5th plus 6x squared y cubed z squared. And so again, big stuff is made of small stuff, whether it's integers, or if we're working with computer bytes and bits and we want to send things across some sort of network in packets, and we want to split up a file into semi-discrete parts and then send them individually, as broadband technology does, then we want to have as little fragmentation as possible. So the modulo function is really just prime factorization or finding remainders, and then optimizing for how many pieces, how many different parts we can send to the file in. And then in pure algebra, so we've got these statements which have multiple parts, and they are together, but they are also distinct from one another, and they can be broken down into their smaller bits. Okay, so this has been Dr. T's Math. Thanks for watching.